Hey everybody, this is Larry. This is day 22 of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem. And today's problem is partition array into disjoint intervals. Okay, so I usually solve these live, so if it's a bit slow, fast forward, do whatever you need to do. Okay, so you want to break this into two parts where every element in left is less than or equal to every element on right. Okay, have to have at least one element, and then left has the smallest possible size. Okay, so yeah, so I think in this case you can do this greedy, and by greedy I mean just try it one at a time. Like, can you do one number, can you do two number, and as soon as you hit the number, or if you hit it such that it is true, then you can go, right? And then now we just try to figure out about, okay, now you're scanning from left to right. How do you calculate the invariant in such a way that, or find an invariant that you can hold to be true as you go from left to right, right? And in this case, the invariant is that every element in left is equal to element, or less than or equal to every element in right. And so that you would keep track of the max element in left and keep track of the min element in right as you go from left to right. And from that, I think that's good enough for us to get started. And of course, if you do it naively, even though n is 30,000, that's going to be n squared. Trying to get the min every time. Getting the max, I think, is pretty straightforward. Yeah, and I think you can. Let me think if you can do this, and doing an n log n is also straightforward, maybe, or it's doable because you just keep the max element on the left side, which you keep adding to max, and then you're trying to get the min element on the right side. I think you can probably do a min q to get this down to linear time, like a mono q that is a min q. But not true. Yeah, I think that's actually true. So you can actually do this in linear time because you can just get, okay, what's the min? What's the min of everything to the right side, right? And you can also use a heap to kind of just keep it live in a way, but you can actually just get the running min of everything to the right side, right? So that's actually even easier. So let's do that. So yeah, let's just do. So mins is equal to some infinity times n. N is equal to the length of nums. Yeah, okay. And then now we do for index in range of n minus 1 all the way to, I usually do it to 0, but actually in this case we actually want it to be negative. We wanted to do an one. I guess it doesn't really matter. Okay. And then now equals num sub index. So we're gonna get the min of this, and so basically we capture the rolling min going from the right side, right? And in this case, we just have to be a little bit careful. So this is n minus 2, min sub n minus 1 is equal to num sub n minus 1. And then now we're able to go from left to right. So we go from left to right. Trying to think about what's the cleanest way to do it. But so what I'm thinking about is also that we have to guarantee that they're length 1. So I'm trying to think about what's the best way to implement that is, but it's not a big deal. Current max is equal to max of current max numbers of index. And now, so okay, so we actually want this thing, and also we don't want to go on the last element anyway. So yeah, so if current max is less than or equal to the min of the right chunk, then we can return index. So maybe I'm I don't know, it doesn't really matter. This may be off by 1 is what I'm looking for, because yeah, because this is the index, but we want the length of it, right? So we can do that, and that should be pretty okay. Let's okay, let's give it a submit. Cool. So yeah, as you can see, this is linear time, linear space. One thing I would say is that, yeah, you want, so this is 2 pass. Yeah, I guess this is unavoidable. I was going to say maybe you could do something playing around with heaps if you want to play around with it, but there's still going to be multiple pass because you have to put everything in a heap, right? So maybe that's not an ideal way anyway. But yeah, so this is linear time because this is linear and this is linear, right? Yeah, and we have linear space here. I think you can compress this a little bit, but I don't think you can. I mean, it's still going to be worst case linear space, so so it is what this is. Yeah, that's all I have for this one. Let me know what you think. Hit the like button, subscribe, and join me in Discord. Hope y'all have a great week. I'm still here, just hanging out, and I will see you later. Stay cool, stay good, to good mental health. Bye bye.